Alright, we are live. Let me just check and see if everything is okay. Oh, come on. Don't close that tab. So I started 2 minutes early so that I can get the chance to check and see if everything is alright. Oh, yes. Everything is okay. Let me just double check that maybe. Double check and see if the voice is actually pretty good. Let me put my headphones on. Alright, we are live. That's that. Let's start. So, yesterday I promised you guys to compile this code on release. So I compiled it offline so that it doesn't take the time from the stream. It's a short stream, so we don't want to waste time on compiling things. So here's the code on stream on release mode. And that's that. It works. It works well. So that is release mode. So let's see what we did yesterday. We just made these guys const expert. These const expert. I just remembered one thing that uh, Jason Turner said in one of his streams that you do actually want to make these static as well because that is that is what the standard promises to make only once. So you won't be initializing these every time that is promised by this static. But this is const expert, and in practice, no compiler does reinitialize these. So yeah, considering the logic, these are actually static. These are the same over multiple implication of this function, but I don't want to make them static. Const expert should by default mean that, and yeah, I'm not making these static. Although that is what Jason Turner would recommend you. So let's see. So yeah, for those who are joining us just right now from this episode on, what we were doing, we just got the code of the. This is the third stream, so we got the code from the Forge engine, and we built it and we ran it first. Everything ran. We started reading the code from one of the examples, Material Playground example, on the unit test solution. So yeah, so I started reading from this init function. Let me just get to that init function. So we started reading from this init function here, initialization function. Come on, let's go here. Check this. Oh no. All right, yeah, this. No, not that. Oh come on, man. That is what happens when you run out of luck. Yeah, we read this init function, and from that we figured out that it is calling some of our member functions which are actually private. So we made them private. And interesting thing here, should this be private or not? Where is this used? I've made this private, but it still works. Is this ah? Okay, we'll get back to this. And this of course can be const expert. While we're at it, let's just make it const expert. So yeah, unless this is virtual and we're just overriding this, I don't see it. Yeah, this is an override. Interesting that it doesn't care like we're overriding it in private. Uh, that's something too. That's something too. Yeah, that is something that we would like to see. Alright, let's make this public. This is part of the. I actually am not sure if you can change the access qualifier of a method of a member function when you're overriding it. So for now, I'm just going to add virtual. I'm adding override and final. This is also something to discuss that JSON Turner or the community doesn't really like. They would just go with the final here. I know this is all three are going to happen when I'm overriding this, so yeah, I'm explicitly mentioning those. Although final does actually imply override and virtual, so that is more verbose. That is just for the reader. So yeah, we started reading these member functions. We started from the create shader, which was called first. We read that, and the next thing that was called. Let me just close these functions, collapse these functions. Yeah, the next thing was compute PBR maps. I don't know what these are. These PBR maps we're talking here. So we started reading. We modified some code here. We made these null footers. We definitely cannot make these consts because these are probably going to be set by some function. I don't like this kind of member, this kind of variable definition here. Define your variables closest to the first use. Because now if I'm going to read this code, I have to like remember all the variables you have here, and then just when I see them here, just try to map them together and see, oh yeah, this is a variable we declared up there. This is that. I don't want to do this mapping. This is just some burden, just some mental burden on the reader and of course the writer. Also, the other thing is if I modify the code below and remove the need for one of these variables, who's going to notice that this actually has become uh, unused variable. So your warnings are going to help you there if you are using your warnings. But I noticed from this code on the first session, we removed the single unused variable. I don't think they're using their warnings properly. So yes, this is probably not a good practice. So yeah, also I'm trying not to read any code offline. That way we're going to read the code together. So yeah, we read up till these. They were declaring, describing some textures. We will get back to these. And we also noticed that these are all read-write textures. I guess some of these could be not read-only textures. I don't know why they're using a read-write here. So let me see if they actually do have read-only textures. So seemingly they only have read-write textures. That is interesting. Skipper type. Ah, so they probably have simply just read-write textures. They didn't bother to like clear any other stuff. So yeah, you don't usually need any read-only textures. I don't know if there are any like optimizations by the GPU on read-only textures. There could be, but they're not using it. And the guy knows the industry well, knows the hardware well as well, so probably it doesn't. The hardware doesn't optimize on those. So yeah, that is the reason we are using read-write textures. That is the only kind of texture we have. And moving on, we got our textures. We add them as resources and another shader load description. What does this one do? So we had a create shader function right here. We read last episode. So this is shader load description, and I'm wondering why they're not add in this shader, which is here. Let me, yeah, this shader. I have no idea why they're not loading this shader up there. I don't know. So these kind of abstractions like load shader, they don't really say anything. You know, create shaders. They don't really specify anything. Like you could have a like a skybox entity that would load the shader, do the proper things related to that skybox. So you could have a section of the code that would do the service that is required for skybox. That to me is a better abstraction than this. This is just explain the implementation. I don't care about the implementation. Tell me what the code does. Tell me what you're going to do. Like you're going to draw a skybox. All right, that's okay. So you go and implement whatever is needed for a skybox, which is probably going to be related to each other. Like drawing skybox is probably not related to drawing hair here. So if you get all the related things together and like put them in one abstraction unit, you can see the relations better since they are trying to do one single job. That is a better cross section of the code to put in one abstraction unit. So yeah, avoid this kind of abstractions. I would definitely just put all the related stuff to Skybox in one abstraction unit. And that would actually avoid like things like this that we have create shaders up there and we are all also creating shaders up down here. So that would avoid this kind of mess. I don't know if you can call it mess or not, but yeah, you would like presume this shader is going to be added there, but it's not. It's being added here. Panel to cube. That is interesting shader. Is this panoramic to cube? So are they rendering some panoramic stuff into a cube? Maybe this is. I don't know. Maybe this is. Sorry. So yeah, they could be like this shader could be rendering some panoramic view onto cube texture, cube maps. And here we go again, sprintf, kind of thing we want to avoid. So yeah, thankfully they're using these buffers here. So if this were to be like a constant string literal, the lifetime of this part, this string, this character pointer is the lifetime of the whole program. So I wouldn't be able to like replace this with strings, which I am going to do now. So also from the last session, we realized that they're using Electronic Arts STL for this, so we don't have a stud library, we have EA STL, which is this one, EA STL. So yeah, I'm going to use that EA STL, and I'm going to use toString here, a better function, simpler code. I don't have to like tell them what type it is. So the reason that this code is bad is that you have duplicate code, duplicate notion here. So this should match with this. So if someone goes and changes this, this is actually going to break the code, changes the type of this, because he probably doesn't know that he has to change this as well. Same with auto, but uh, auto here, that is the almost the actual use case of auto. So you're just telling the compiler, figure whatever it is, I'm not going to cause incoherence in the code, inconsistency. It will always be consistent with the type that toString returns. And from that type, I know one invariant, and that invariant is CSTR, which I'm going to use here. So I know that whatever this type is, it does have CSTR. I am using that. Also avoid using that. That is C++. This is C++. That is C. Make this constant as well. This is that. I'm gonna make this const expr, so we can const expr these. Let's do that. and probably const expert this one right here. And sadly, to string is not const expert, and even if it was, I'm not sure. Oh, okay. All right, I can make this one const expert. Yeah, even if this to string was const expert in the standard, I don't know if EASTL does support const expert to string would support const expert to string or not. That is the bad thing here. I don't think you can use a normal stud library for in these projects because they are using EASTL, and I tried to include like a standard string header and I failed. So it is it's possible that we are actually not going to be able to use any of that there. Also, we have another string here, and what? Oh yeah, and here we are putting a floating point. So what I believe is that they're using these shader macros just to pass variables to the shader. So these shader macros are probably being replaced. So that is what these are. Also, we can make this one const. So this is part of the thing we did last time as well. Const expert, const expert, everything we can. I don't like the code style as well. Like you're adding dependency between lines, like here. So if I'm going to change this line, like this line here, it is going to be inconsistent with the next line. So add it, you could use like some like if I were to do this, this is adding independency between these two lines because they're going to be aligned here. And they, if I change one line, they're going to get out of sync. So yeah, that is not a good idea in my opinion, but don't forget to make this const. Yeah, so I would advise against this unless you actually have a very well configured code style checker and something that applies the code style for you. You shouldn't expect your programmer to like add spaces here. No, if this is not automated, it is going to get out of sync. Same as here, we're going to add consts, blah blah. Remove that const this one auto. We're going to ouch. We're going to have a string here. I'm going to use ASTL to string and put this here. I don't care if this is floating point. The toString function uses it. It does. Let me see if it does actually. Yeah, it should, but I don't know why it's saying me that there's a code problem here. This should run just fine. Let me compile this. Alright, it doesn't. What's the problem here? Oh yeah, this is the problem here. And CSTR here as well. There we go. Okay, are we good? We are good. Let's move on. Let's finish these as soon as possible. Like this is gonna get boring in this stream. Just me adding const experts and const. So adding more shaders here. BRDF integration. I don't know what these do. I would love to know what these do. Like I'm dying to read the shader codes. Interesting. Not adding these shaders for iOS. Who cares about support on iOS? But hey, that is actually the idea. The actual like yeah they've gone as far as to make these cons but not const expert. Why not? And yeah, that is almost the actual way they are doing this. Like, what does this const expert mean? Const there. What about this const expert? Is this valid code? I bet not. Yeah, pointers themselves are const. So is this how it's going to be? Ah, interesting stuff. The const explorer here, I know that it just says the whole thing is going to be const explorer. The pointers are going to be const explorer, and that the data pointers are pointed to. And this is saying that the characters are going to be const explorer. So I believe this is the right way. Well, let me see if this is supported. It is not. So yeah, I believe this is the right way to write this code. I'm going to stick with that. Here we go. I don't know what this is. That is the shader there. Root signature descriptor. That is interesting. What does that mean? Root signature descriptor. And what is this about? Let's go to this. Shall we? This is putter to shader. Oh, and this is a putter. It's a pointer to pointer of the thingy here. So are they writing back some? Are they writing back some pointers to this? Huh. So maybe I cannot make this one const explorer. So I will not. But that is weird. So they're going to write on this? Are they going to actually write on this one? It was a putter to putter. So this is an array of character pointers. So that is what that is. So then they're not writing to this. Const exploring this one. Going to the definition and adding some const. So this is saying that point putter is const, and this is actually saying that this putter is const. This should fix the problem. Fixed, I guess. What is this here? Some kind of an error here. Get name. Version type is not identical. Oh yeah, this probably was const. I probably must have thought I've added the const and removed it. So let's see if this actually compiled, and if so, we'll just keep going on. Seemingly it does. Yeah. So there will be. So along the way, we're actually like doing some modifications on the interface, like the const we added into this. So I'm actually not tracking any of these. I'm just hoping that Git does, because these are not like breaking changes, and I don't really care about these. These are just code style changes. They're not that important. So I'm actually not really caring about those anymore, any more than actually just letting the Git track them. So yeah, I bet this one can be const explorer. Okay, it can't, probably because this is not const explorer. Yeah, I'm not getting into these descriptor, pre-render, radius. What are these? What are we doing here? So one thing we need to figure out is root signature descriptor. What does this do? So it takes a shader. It takes many shaders. The count of shaders I've used stood for that. I don't know. Maybe this is size T for this. This is probably C also. So yeah, this is C. You see, I render that edge. I was I thought previously that like uh previously I thought that this is using the pimple idiom, but this is C, so they don't have pimple idioms here. This is just pure C. So this is the interface of the render, and it is a large interface. 2K interface. It's not that large. This file is for 4K lines of code. Alright, let's move on, let's move on. Don't waste any time here. And yeah, we were going to see what these were. So, p-static sampler name, root signature descriptor, local root signature used mainly in ray tracing shaders. Number two, the difference in the root. Yeah. Mhm. I don't know. We will get back to this. I don't know what these root shader descriptors are. So one thing that I'm really worried about is that they're probably going to use structs for serializing data to pass to GPU, and modifying that data is that those structures are going to be fragile. So minor changes to those could break the code. I'm trying not to do any code breaking changes right now. We're not that familiar with the code. So yeah, I will try to avoid those kind of changes as much as possible. So this is adding those root signatures we just described here. I don't know what any of these root signatures are or what root signatures are. I have no idea. And descriptor set descriptor. Ah, that is not a good name, is it? Maybe. I don't know what the concept is. Probably it could be a good name. And it is being set by this one, and so on and so on. Blah blah. We come here pipeline descriptor. This is our pipeline descriptor. This is where the interesting stuff comes into play. So we have specular pipeline, irradiance pipeline, and panoramic to cube map probably pipeline. Interesting. What are these? They're like, yeah. So see what I mean by like not putting everything related into one place. So through here, if I'm reading it through here, for panoramic to cube map pipeline, I will have to like to know what this is, like this one, panoramic to cube map pipeline, right? For to know what to understand what this does, I'm going to like have to ignore these these two, okay, ignore these ones here. Alright, ignore that, this, those, except that line. I will have to read that line. And ignore these until we get to here. We need to understand that one. Ignore these. So you see what the point is here. Like to actually understand what this does and how it relates to the rest of the code, I will need to like ignore one three-fourth of the like three-quarters of the code is going to be ignored by me just to understand what this panel to cube shader does. Um, and if I'm reading it in like in a sequential manner, just reading it from top down, I will come here, read this one, load this one to my RAM, little RAM I have. That's I read this one, and this reading this one will make this one pop out of my cache, my small cache here. So my brain is full already, and I've already missed that there's a line here, and so I will need to go like back and forth just trying to figure out what this panoramic to cube shader does. So probably one improvement would be just putting these in separate separate member methods. Also, I believe that since we do not have a, okay, we do have a, right, probably this can be cast, right? We know that far. Like we have only one state in the whole playground structure here, playground class here, and that is this staging data. This is the only, it contains model list, material names, blah blah. This is not good, guys. This is not a good thing to do here. And it uses conf free here. We had a conf new there. So what are these conf free and conf new? I don't know. Let's check them. Are these their internal? So I believe these are their like custom allocators. It doesn't do anything interesting, just huh, yeah, it probably does not do anything interesting. Just allocates and deallocates. Interesting stuff there. So yeah, this is the only member we have here. This is the only member state. So anything not touching this one can be const, probably can be static. So that's all. Also, that those const here and putting in static here, if it actually runs, if it actually is static, will help reduce the mental burden of the code reader. Of course, static functions can be const; they don't access any state to be const. All right, so yeah, this helped me figure out that yeah, this is not accessing that member variable. But in future, I'm going to like make all of these global stuff you have up there, global variables we have here. I will try to make all of these members. There's no reason that they are actually global. And making those, after making those member variables, I won't be able to like make this one, this compute PBR maps. I won't be able to make uh, these concepts or these static. So that's the reason I'm not adding static right now here, because I definitely know I'm going to change them. All right, so connecting the implementation and the name, that I believe they're putting up some small pipeline here, and they're rendering some stuff. This is the baking part, so they're baking some stuff here. They're putting up some like uh, some pipeline, some renders down here, rendering some stuff down to their textures and keeping those textures and removing an old pipeline. So I believe this is a small render right here. So that is what the cube map does, and the panoramic to cube map. So they're breaking cube maps probably. So yeah, these are just describing some pipelines here. This is good code to get to know. This is going to be good. Wait for token when this one happens. Where is that token? Who uses this token? Let's see who uses this token. So there's a synchronization token defined here. Where is this? Add here mesh. No, this is not what I'm looking for. Back to my code. Here, let's see. Let's see if Visual Studio can figure out where it's been. There. So it's been declared here. And who does use this? So that is what this synchronization token is for. So probably add resource is an async interface. It's taking a synchronization token. It's going to start adding this resource here. Its load priority is high, so the system is going to try to add this resource as soon as possible. Another resource is going to be added here. All the resources are going to be added here. And here we're just waiting for all those resources to be loaded. So yeah, that is what's happening there. So yep, and we come here, texture barriers. What are texture barriers? So I believe this is also some kind of synchronization stuff. Unordered access, resource state unordered access. Let me see where this is. Wavy barriers. Command resource barriers. Hmm. I don't know. I don't know what these commands are. Command. One design I've come to know like in the renders is that they would they would like to know what all the pipeline is going to do and try to optimize that. So probably what their render does is to get few comments and try to optimize those comments. The comment could be like render this, render that, use this texture, use that texture, and so they could be putting few commands in some queue and letting the renderer decide in what order and how to actually execute these commands to actually optimize the pipeline. So this could be what these commands are. I could be wrong as well, but this is dispatching commands, so I don't know. I could still be wrong, but maybe not. And texture barriers. So this is probably describing the use of these commands, like how these commands are used. Alright. So, yeah. Uh, we can move on here. We're declaring some structure here, calling it describe exercise. Interesting. Yeah, I'm going to like to make these Win32s, but no, I'm not. I'm not going to do them right now. So yeah, this is the command thingy here, the comments architecture we have here. We're dispatching some comments, and let's see where it starts actually, where it starts actually executing comments. So this is one comment here. It ended the command right here. Submit descriptor, queue submit descriptor. So it's putting the command in the queue here. Wait queue idle. Interesting. So it just described the whole pipeline of a render up there, and now it is just putting it in a submit descriptor and putting that submit descriptor into the queue and waiting for it to submit descriptor. And this is the graphics queue. So yeah, I do like this kind of design. This is probably the most common design you see in anything that has a GUI and interacts with the user. And I do really like this design, and I have few designs of myself around this design. I will probably start writing my own render sometime, and I will probably use this. So yeah, remove descriptor set. So it just deallocates whatever added here, and that's that. So yeah, they're baking their lighting probably here. Let's get back to where this function was called as the init function, initialization function. So yeah, so we created some shaders, we computed some PBR maps. So this is baking our lighting, load models and textures. So the name seems pretty obvious, but I do need to see this. So earlier in some part of the code, we saw this one. Let me get back to, let's close this one. Let me get back to where the initialization function was. Here. So here we just saw that we added some paths here, and we didn't know actually how those elements in these paths are going to be loaded. So probably where is it? This load models and textures is going to load those. So let's see. Load models.lua. So this is a Lua script here. Load model. So function load model here. Lua state graph state blah blah. Alright, eviction in Lua starts from 1.0. Huh. Alright, get a string args. And we push back file name. Model this. Load model find. We don't load the models, huh? Why is that? Why is that? So someone else does load the models from this. So yeah, this is the staging data. We just this is our only member here. Interesting stuff down there. So we are also 40 minutes in already. Time flies when you're streaming. So yeah, let's move on. We have UNT Peters here. Let me see if they have any using namespaces here. So no using namespaces there. Not destroy mom, destroy textures. I would definitely recommend using RAI for this. Like use the destructor for destroying, the name suggests, and constructor for constructing. Sometimes you don't want to put like things that actually take long time of the processing time in the destructors and constructors. But here it's not going to be in the performance critical path of the application, the code. So it wouldn't really hurt to do that. Anyways, so tiny image format, that semantic position, tiny image format, blah blah. What is this? Gvertex layout default. So this is describing the vertex layout here. So this is probably going to be used while loading models. Where is this used? Nowhere. Nowhere in the body of this function. Probably somewhere else. Let's check that. This is not a good way of checking if this is used. Probably it is used here on compute PBR maps. Is it? No. Yeah, it is. It is used here. Just try to describe. No, it's not. It's on the load model. Yeah, I wouldn't imagine. So yeah, reading this kind of code is just difficult. It is a pain. It's a headache. You don't want to do this. So load model uses that. You're just passing something from one function to the other function without passing it through the parameters of that function. Let me check if you're live. Are you still live? No GeForce, I'm not. You're alive. You're alive. So yeah. So that is that. Okay. So yeah, don't write code like this. This is a headache to read, to understand what it does. You could simply just pass this through this, like here, as a parameter. I will work on that as well. These are like, I should make a to-do list. But the point here is, the reason I'm not actually touching the code that much is that I am not familiar with this. This is the third hour I've put on this code, so this single file is 4K lines of code, so don't expect me to like learn it in 3 hours. This is the third hour actually. So yeah, the reason I'm taking it slow is that I actually don't know the code, so I'm taking it slow. The things will just pick up speed as we learn the code, like we've just started learning. Also, yeah, now I am also new to this kind of like code review while streaming, and not in somewhere I can actually add discussions. I usually add discussions right away. But yeah, I will just get to know the code base first, and then I will probably just make a to-do list. Also, the other thing is I have no idea what the architecture is, and at some point I will need to like tell them, uh, tell the actual tell like the company that I am doing this. Like they have their Discord there. I could gain some like viewers from there. So yeah, that is that. Okay, let's move on. Add async script. Interesting. So model loaded. Hmm. All right. So I'm just seeing part of the code here. I don't know what load models does, so I probably don't know what this is going to do. So I'm only saying this partly. But add async. This cost. Let's see if this still works. Yeah. You kind of wait here. Thread. What is this thread? This doesn't have a member function. This is not the thread. Oh. No, it does have static member functions. It has a bunch of static member functions. Is this C? Is this valid C? Can we have static member functions on structs in C? That is interesting. Is this considered valid C? Huh. Interesting stuff. We will get back to that. So yeah. Moving on. Material texture count. Blah blah. I'm not digging deep into these. These are like, we just need to know like what the architecture is, what the code design is, which I'm starting to kind of familiarize myself right now. So yeah, that is what this does. I'm wondering where this load model function is called here. It's called here. It was called here. Is it at all called anywhere else? Yeah, it's called here. Ooh, look at this. Look at this. Interesting stuff. So, material playground. Passing this with mesh count. So this is a function putter to a member function, and this is the type of this. This is interesting that this is not a pointer type, but this is. What the system range task? Interesting. Yeah, interesting stuff here. I don't know. I don't know what they're doing there. Yeah, I don't really care much about what they're actually doing here. Sorry. So yeah, that is why I'm just skipping over it. I want to get to like the fun stuff, not loading Mars. So yeah, that is the reason I'm just skipping over these. Alright, let's get back to our init function. Right here. That was load model create samplers. We saw creating samplers somewhere else as well. I don't know what that did. Let's just add 3 samplers here. Mhm. Yeah, I'm not digging deep into these as well. We've come to like identify what the render interface is. We will just dig into these when reading the render interface. So I'm not digging deep into that too. Back to our init function. All right. So we created our samplers and create root signatures. This is interesting. Like this function here, this has simple render inside itself. It just like does all of these here with this one root signatures. I don't know what root signature is. I will have to dig into that. Like what part of the architecture that is, I have no idea. So as we saw before, this is just like adding some root signatures that we don't know what they are. We know that they use shaders. I think they are part of part of the rendering pipeline. Maybe, I don't know. Why root? Why is this a root signature descriptor? Hmm, I don't know. Back to our init functions here. And yep, we read that. Root signatures, we don't care about this one. So let's see our uniform buffers. I don't know how they're updating their uniform buffers. So this is the part. Even if we are actually connected right now, like the dropped frame rate, like we have 60 frames dropped here. That is no good. My bitrate is so little. Alright, I guess that is fixed. Sorry for these mishaps. These are going to happen. I don't have a good quality internet right now. And yeah, that is why this is happening. I hope this is going to work now. So you guys didn't much, you didn't lose much either. So we were reading these create uniform buffers, and I was just saying that these their naming convention. They're using M for members, P for putters, and double P for pointers to pointers. I was saying that I don't care what these are. I don't care if this is a pointer to pointer. I don't care if this is a pointer. The only thing that I care about is that, but this is like if this is a buffer, I am going to expect this to act like a buffer. So I don't really care to know how it's implemented. I just need to know that this is a buffer, and you should probably provide some characteristics for this buffer. So yeah, let's move on. Move on. Buffer load descriptor. Interesting. So this is going to describe how to load the buffer, I believe. So yeah. Blah blah. So that is how that is. Let me see what they're doing here. M descriptor tribe, uniform buffer, resource memory usage, CPU to GPU. Oh, so yeah, this is telling the descriptor that I am going to put data from CPU side to GPU side. This is the size, uniform buffer, object buffer. Interesting. Uniform object data. What is that? What is uniform object data? Huh. So yeah, so they're just serializing their data using this. It is interesting that these flow threes, these are these implemented, like three floating points right there. This is not a good way to serialize your data, but it's a way. You could say it's a way. So like each floating point is 4 bytes, so there's going to be a padding here. I've written renderers back in the days, like when I was like 4 years ago, 5 years ago, maybe six, I don't know, when I was a little kid. And I did things like this. I definitely did things like this. But I would not recommend it right now. But if you actually know what your architecture is, what your system is going to do, yeah, go for it. This is the fast way of doing things, but this is UB. This is undefined behavior right there. Back to our uniform buffers. So yeah, these are describing. This is load description. How to load them. Descriptor type uniform buffer creation flag persist map bit. Persistent map bit. Alright. I don't know what this flag stands for. I'm not making these nullers, or am I? I am making these nullers. I know that these are not being sent over, so these are going to be nullers there. This is how to load. This is a descriptor for loading and surface UV descriptor. I don't know. So this the surface UV descriptor, and this is the nameplate UV descriptor. And it is interesting that they have multiple uniform uniform data in their shaders, but the format of all of them is the same. So these are materials, you know that much. Tiling and metallic is still material. All of this is material. Texture configuration, this is material. Right. I will need to learn the short key on about of like moving between these. Let's search the name of our. What was it? What was it? What was? Let's go get there from init function. Not this init. So yeah, you're on here. Create on here. So that is how they're describing uniform buffers, and it's interesting that they're adding them as resources. What is actually a resource? I thought that resource was uh, their assets. I don't know what this resource is. Like uniform buffer is not your asset. Load priority normal. This is seemingly part of their asset. Ah, I don't know. I don't know. I will need to look further into this. So we've hit uh, the hour mark. We've been reading the code for an hour. I'm gonna go for further 5 minutes because of this connection loss. And after that, that's going to be that for today. So let's read further. This is the same. I'm not going to read like every one of them. But I don't know what this add resource does. This is a complicated function that like this seems to be doing everything. One thing I know is that I can make all of these nullers, and I want to do them now. All of those nullers. This is not C. This is C++. Nuller there, nuller there. Let's make all of these nullers as we are skimming over this. So this is still doing the same thing. I'm not. Yeah, I'm not going to dig into anything deeper than this for uniform buffers. If you get like get to know the render interface later on, this is going to be easier to figure out, like to see what this does. So back to our installation function. where we left off. Yeah, create resources. Let's see what this does. This probably is going to make some sense regarding to all those uniform buffers we added as resources. Let's see what this does. So, oh no, what is this? Generate skybox vertex buffer. So this is the vertex buffer for this skybox. Yeah. Timer T. Let's see if this timer T is used. The last one wasn't, so neither is this. Thanks, guys. Thanks. I'm ranting again. I shouldn't be ranting. I promise not to rant. Where were we? Where were we? Yeah, that is not a T. This is a T. Yeah, I'm figuring that they use this for profiling or something like that. Oh shit. So yeah, I'm removing it. We don't need it. I would make this like in rendering. You usually like to you're going to in some point in your rendering you're going to need to render a cube, and I believe this skybox is a cube. Seems to have more. No, yeah, this is probably a cube. Yeah, like each of these is a surface, like the minus z side of the cube, minus x side of the cube, positive x side of the cube. I would like it would be nice if the renderer just provided you with an interface that would just like draw a cube, since it is usually useful. But I'm not sure if that would be actually possible with the UV maps and stuff. It would be possible, but it could be not that like not that much useful. Here we go again. 364. This is cost expert. And now that I'm noticing, is this okay that I'm using Studio in 64? Maybe I should be using EASTL for this, but EASTL is not providing me with one. So I don't know what EASTL is. I don't recommend using it. I don't know why they are using it. I will definitely like talk to the ask them in their Discord channel as to why they're using ASTL. Let's just stick with the std here. So their code probably doesn't have any std in it, so this will be easy to find and replace later. So yeah, that is an hour and 5 minutes. I'm going to stop right here. So thank you for watching, and see you tomorrow, I guess.